All right, let's dive into a bit of a detective story, a story about the internet itself. It's all about scarcity, some really clever hacks, and the reason why that public IP address you think you have, well, it probably isn't really yours. Not yours alone, anyway. Let's get into it. So let me ask you a question, straight up. Right now, does your computer have its very own unique public IP address, one that anyone on the internet could technically connect to? You might think the answer is yes, but it's almost certainly no. And the reason why? Well, that takes us all the way back to the beginning. So to really get this, we've got to rewind the clock. We're going back to a much, much simpler time for the internet, when it was kind of like a small, friendly neighborhood where everyone knew each other. Back in the early 80s, things were beautifully simple. Every single machine connected to the internet had its own public IPv4 address. It was direct, it was simple, it was globally unique. Just think about that for a second. No complex firewalls, no network translations. Your computer was a first-class citizen directly reachable from anywhere else in the world. It was clean, it was elegant, and as it turned out, it was completely unsustainable. Here it is. This is the number that shaped the last 40 years of the internet. When IPv4 was defined back in 1981, this number, almost 4.3 billion addresses, seemed infinite. I mean, who could possibly need more than that, right? Well, turns out, pretty much everyone. This number, which once felt like a symbol of endless possibility, would pretty soon become a massive bottleneck. So by the early 90s, the internet was just exploding in popularity, and it became painfully clear that the well of IPv4 addresses was going to run dry way, way faster than anyone ever thought. So the engineers of the internet had to get creative, and they came up with a fix that was both brilliant and pretty controversial. You know, this timeline really lays out the whole drama. It all kicked off in 1981 with IPv4 and its seemingly huge pool of addresses. But just over a decade later, by 1994, the alarm bells were ringing, and engineers proposed a fix called Network Address Translation, or NAT. Then, just 2 years after that, in 1996, they defined private IP address ranges to make NAT possible. This hack bought us a ton of time, but it was always a temporary fix. And sure enough, by 2011, the global pool of available IPv4 addresses was officially empty, gone. So the key invention that made this whole fix work was the private IP address. This is a special kind of IP that's non-routable. It only works inside a private network, like your home Wi-Fi. You've definitely seen these before, addresses that start with 10 dot something, 1716, or the classic 192.168. You can think of them like internal phone extensions for your house. They let your laptop, your phone, your smart TV all talk to each other without needing a precious, globally unique public IP address for each one. Okay, so how do all these private devices actually talk to the public internet? That is where NAT comes in. It's like a translator. So let's walk through it. Your laptop, with its private 192.168 address, wants to go to a website. It sends that request to your router. Now here's the magic trick. Your router takes that request, swaps out your laptop's private IP for its own single public IP, and sends it on its way. It keeps a little note of this swap in a table. Then, when the website responds, it comes back to the router's public IP. The router checks its table, sees, oh, this is for the laptop, and sends it right back to your machine. It's doing this translation, back and forth, millions of times a day. Now, NAT was a fantastic solution. Seriously, it massively slowed down how quickly we were burning through IPv4 addresses. But the internet just kept growing. Broadband got faster, smartphones appeared, and then came smart fridges, smart toasters, you name it. Everything needed an address. And pretty soon, even the internet service providers, the ISPs, started running out of public IPs to give to their customers' routers. The problem was back, only this time it was much, much bigger. So what was the solution? Well, if you can believe it, another layer of NAT. This time it's called carrier-grade NAT, or CGNA, and it's the exact same idea as your home router's NAT, but just on an absolutely massive scale. Now, it's not just your phone and laptop sharing your router's IP. Now, your entire household plus hundreds of your neighbors are all sharing a single public IP address that your ISP hands out. This table does a great job of breaking down the different address worlds we're all living in now. First, you've got your private network range. That's your classic 192.168 space inside your home. Then you've got the public internet, which is everything else. But look at this special range right here in the middle, the one starting with 100.64. This is the ISP shared space, reserved specifically for CGNAT. And here's a little pro tip for you. Log into your router's admin page and find the WAN or internet IP address. If that IP starts with 100.64, then congratulations, you're behind CGNAT. So what's the big deal? They're both NAT, right? Well, the difference is huge. Your home NAT manages a handful of devices in your house, and the most important part is you control it. Your ISP CGNAT manages hundreds of homes, and you have absolutely zero control. With your own router, you can set up things like port forwarding. Behind CGNAT, forget it. That ability is gone. And it's this complete loss of control that makes things so frustrating for developers and other power users. Okay, we've gone through the history, we've gone through the tech, but why does any of this actually matter? Well, if you're a developer, a gamer, or just a tech geek who likes to tinker and build things, CGNAT basically changes everything for the worse. So let's talk specifics. What does CGNAT actually break for people like us? Well, first and foremost, port forwarding is impossible. So if you wanted to host a little Minecraft server for your friends, or run your own web server, or maybe a personal VPN, you just can't. There's literally no way to open a path from the public internet directly to your machine. It also causes huge peer-to-peer and gaming issues. If you've ever seen that dreaded strict NAT type error on your Xbox or PlayStation, this is probably why. And finally, there are shared IP problems. If someone else sharing your public IP does something sketchy online, you might be the one who gets blocked from websites or has to solve endless CAPTCHAs. It basically kills all the fun experiments you'd want to do with a home network. I came across this quote, and it just perfectly captures the whole frustration. CGNAT makes you just a consumer of the internet, not a participant. Think about that. In the early days, the internet was a two-way street. You could create just as easily as you could consume. CGNAT turns your connection into a one-way street. You can browse and stream all you want, but participating, hosting services, creating things, experimenting, it becomes incredibly difficult, if not flat out impossible. So are we stuck with these complicated layers of hacks and workarounds forever? Is this just the way the internet is now? Thankfully, no. There is a real long-term solution that actually takes us back to the internet's original, simpler vision. And that solution is IPv6. Instead of a measly 4.3 billion addresses, IPv6 gives us, wait for it, 340 undecillion addresses. That's 340 with 36 zeros after it. It is a number so ridiculously vast that we could give every single device on Earth, and probably every grain of sand, its own unique public IP address and never run out. With IPv6, the entire address shortage problem just vanishes. And when it does, the need for NAT and CNAT goes away with it. We come full circle, right back to that simple, direct internet we started with. So that's the whole story of the internet's great address shortage. But now I want to hear from you. After hearing all this, did you go check if you're behind CGNAT? What was the result? More importantly, what's the biggest networking challenge or headache that CGNAT has caused for any of your projects or hobbies? And finally, are you using any clever workarounds like VPNs or tunnels to get around it? Drop your stories in the comments below. Let's get a discussion going. Thanks for watching.